Hi guys. Maven is a satellite with cameras and sound waves and every kind of equipment that we have explained so far uh, was sent to Mars 5 years ago. Uh, it was meant to send the pictures and videos and footages and clips, and so that we have material, raw material of the planet, raw material of the ups and downs of the planet, and the sound waves and the cosmic waves that are used by satellites were sent, and the readings were and trends were gotten back from the planets and its the atmosphere, and we have been studying through that Maven. So NASA has launched a video regarding Maven, and after seeing that they contacted after seeing that I came up with the idea, and I told them that I can do this for them, because you have to go to sequence and you have to find out. So basically my stream is going on, so you can find the video standalone on NASA's website, but uh, watch this video from the launch and creation of the video, the mission of watching Mars to the point that we are on right now. All the data, all the things have been made to this point, and we are prepared because of this. And this footage, what you will see issued by NASA, is actually live footage that we are seeing right now. Tomorrow, Mars mission will start, and that is the target that we have. I'll talk to you at the end of the video.
We've never sent a spacecraft to Mars just to explore its upper atmosphere. If you imagine Mars as having had a thicker, warmer atmosphere early in its history, where did the atmosphere go? Where did the water go? And there are only two places it can go. The atmosphere can go down, or it can go up and be lost to space.
count. Atlas systems, propulsion.
Go.
Hydraulic.
Go.
Pneumatic.
Go.
LO2.
Go.
Water.
Go.
Centaur system, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Have gas.
Go.
Electrical system, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
Instrumentation.
Go.
Com.
Go.
Timer.
Go.
CQ.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
Dual A safety officer.
Go.
Vehicle system engineer.
Go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicles ready to launch.
Proceeding with the count. Status check.
Go Atlas. Go Centaur.
Go Maven.
5, 4, 3, 2, 1. Main engine start, ignition, and liftoff of the Atlas V with Maven, looking for clues about the evolution of Mars through its atmosphere.
Passing through the sound barrier. Maven is now supersonic. We have spacecraft separation. Both brake wires indicate Maven has successfully separated from Centaur.
Hello there, team. This is Charlie Bolden. I just wanted to take a moment to thank everybody. All day we've been saying, go Atlas, go Centaur, go Maven, and that's for a reason. It's because this is the effort or the effort of a really tight team that's been working pretty hard. The one thing I will tell you is that I would hope that this mission will be a model for the ones that come after it. They say imitation is the grandest form of flattery, and I think the best way that we can pay tribute to all of you is to have other missions come in cost and on schedule the way that you all have done, because that's what's going to make people have faith in us and believe what we say when we talk about doing even grander things like putting humans on Mars. But again, you all have done an absolutely incredible job. Let me thank everybody, and I'll let you go back to work so you can finally get home to family, hopefully. But thanks again for everything. Great job.
Safe travels, Maven, and we're with you all the way.
Hey guys, we're going to Mars.
Congratulations, Maven is now in Mars orbit.
Fantastic. Wow, okay.
We often talk about how Mars is hard. And once again, this team made it look easy, but it certainly wasn't. It represents years of work, very complex work. And it's just incredible to me that we're able to accomplish these things, and that Maven has joined a fleet of spacecraft, including the Mars Reconnaissance Orbiter, Odyssey, Curiosity, and Opportunity, at Mars, and reflects this incredible quest to unravel the mysteries of the universe and to try and understand Mars. This really is a quest of humanity. It's an international quest, and it was a team effort to get Maven into Mars orbit. It represents the start of the Maven mission and the science mission, which is why all this effort was made.
What we're trying to do is to respond with this mission to observations that tell us that the climate has changed on Mars significantly over the past few billion years. We're trying to understand what the cause of that climate change has been, and we're looking at the role that escape to space may have played in removing the atmosphere and changing the atmosphere. So we're looking at what happens at the top of the atmosphere, how the processes involving the sun and the solar wind affect the gas at the top of the atmosphere and strip it away to space. So in essence, that's our goal, to answer the question, where did the water go? Where did the carbon dioxide go?
People won't realize how much hard work went into this, how much behind-the-scenes stuff went on during the design phase, how much testing the team did, how many contingencies that we went through, what-if scenarios, what if this happened, what if that went wrong. It really is an amazing amount of work that the team did to make it look so smooth. It's kind of cliche. People walk around going, it's not rocket science. Well, sometimes it is rocket science. And I'm very proud to be part of this team.
Maven is a spacecraft that's orbiting Mars. It's been there since 2014. Maven, in this case, is an acronym. It stands for Mars, Atmosphere, and Volatile Evolution. And this gives a clue as to what Maven's real goal is. It's to study the top of the atmosphere and how the gases in the top of the atmosphere might escape from Mars away to space.
So the atmosphere of Mars must have been a lot thicker about 4 billion years ago, and today it's very cold and dry. And Maven is meant to understand the atmosphere as it is today and how it has evolved into this current cold, dry state.
One of the things we're trying to understand with Maven is whether a magnetic field for a planet is important for regulating the climate or allowing the planet to keep an atmosphere. Earth has a global dynamo magnetic field. Mars does not, but Mars has an induced magnetosphere. It has an induced magnetic field.
The upper atmosphere of Mars is being ionized by solar radiation. And so the electrons are being stripped from the atoms in the atmosphere. When that happens, it turns into what we call a state of plasma. This plasma in the upper atmosphere is very conductive. It leads electric currents to flow through it. Electric currents, they shape the magnetic fields that are around them. And that's actually how we see them with Maven. We take magnetic field data and we map it around the planet, and from that, the currents emerge. We've known how the currents flow in the Earth's magnetosphere for decades, but we don't know how that works around Mars. We don't know how it influences the interaction with the solar wind, because it determines how energy is flowing into the atmosphere, how it's transferred from the solar wind into the system. And that's what we're trying to do with Maven. When you just look at the data as it comes down, you're just seeing a little squiggly line, essentially. You're seeing the magnetic field strength and its direction vary as the spacecraft is flying through different regions. And so what you have to do is you have to actually map it to the planet and to this interaction with the solar wind. And then it starts to emerge that you have a drape situation where the magnetic field of the solar wind encounters the planet and it starts to wrap around it. And the reason it wraps around the planet is those electric currents that we are seeing.
The magnetic field in the solar wind is straight lines. You can think of straight spaghetti noodles, and it's flowing towards the planet, and those spaghetti noodles wrap around this basketball-shaped planet. And that's indeed what we saw in the data, the magnetic field lines draping around Mars as a planet. One thing that wasn't so expected was the specific configuration of the electric currents that we derive from the magnetic field data. If Mars is a ball here, it's sort of this cup shape on the day side that loops back on itself, maybe something that looks like this. What wasn't so intuitive to me was the directions of those currents and the fact that it wraps continuously around to the night side, and it makes this marvelously complex current system on the night side as well.
This is the first time that we've been able to actually map out the currents, so we can see where the energy is being transferred. We can see what actually forms the underlying mechanisms creating these induced magnetospheres that are not just common here in the solar system, they're 50% of the planets that have them, of the terrestrial planets. And if you want to understand how the atmosphere of Mars and Venus, why they're so different from the Earth, and why they're so different from each other despite both being non-magnetized, we need to understand their induced magnetospheres first.
So knowing how these global current systems are configured teaches us about how charged particles near the planet are going to move, both charged particles in the solar wind and charged particles from the atmosphere itself that are in the process of escaping to space. So now we can understand better where those particles came from, how they move near Mars, and where they're going to go next. That in turn teaches us about atmospheric escape from the planet and the history of the atmosphere over time. How thick has it been? How much has been removed?
Okay, so guys, this was the whole video. I know it's a bit long, but you can skip it to find out what it is. And basically every aspect of this project is really interesting to follow it. There are a lot of people who don't know it. Tell them what you are doing. Tell them that whenever the Mars mission is reachable, and we will get feed on first step on Mars, or we will get feed on the launch to Mars, or the news of launch to Mars, because conservative people are there, intellectual and enthusiastic people are there. So you have to choose what you have to be. Do subscribe, do follow, and do look at the pages for the events that we are going on right now, and get to know us better. We might be useful in the future. Take care.